All right.
Let's all talk at the same time. Let's see what the levels look like. Just say
all
something.
right, well, so we're just going to be jabbering over each other and then see what happens.
Okay, yeah, that's good. All right. All right.
You're listening to Coding Blocks, Episode 11. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcasting app.
And visit us at codingblocks.net where you can find show notes, examples, discussion, articles, and other stuff.
And send your feedback, questions, and rants to comments@codingblocks.net. And follow us on Twitter @codingblocks and on Facebook at facebook.com/codingblocks. And with that, welcome to Coding Blocks. I'm Alan Underwood.
I'm Joe Zach.
And I'm Michael Outlaw.
And so the first thing we're going to start off with today is a little bit of news. First, RajSoTweet on Twitter @RajSoTweet.
Awesome name.
Yes, he hit us up this morning and was like, hey, we're looking forward to the design pattern. So here we are. We're recording this same night. So appreciate you calling us out for that.
And in other news, there was a release from Microsoft for the .NET Framework 4.5.2. I know we were all anxiously awaiting that release. No?
Yeah, not so much.
No? Okay.
Crickets.
Yeah.
Fine. ASP vNext?
That
Anyone?
sounds a little bit cooler.
Yeah?
So I'm excited. I don't remember what it's involved in anymore.
It was deploying in the cloud or something, right? I don't even remember.
Oh, and I accidentally deleted the link. So next.
Awesome. So in cooler news then, Kaspersky Labs, a well-known name in the security realm, they put out a link, a site called Kaspersky-cyberstat.com. And if you have a chance to check it out, it's really awesome. It has like real-time statistics of things that are happening on the internet. So number of cyber attacks, total internet users, number of Android phones that have been, that are out there.
Babies being born.
Yep. Babies being born. Blog post today. Detected adware. Yeah, it was pretty neat. Little stat there.
Yeah, and the what was it? The malware stuff that looked like they just basically took whatever number was on there and just kept multiplying it by 1 million every second. So.
They might be a little biased.
Yeah.
I'm not sure. It could be just a random number generator,
It felt like it was going up so fast.
Let's see what else we got. There's Julie Lerman on Twitter posted that Entity Framework 7 was just sitting out there in the wild, just waiting to be found. And she posted a link to that on Twitter. It was juliel.me/GitHub EF7, and it was a link to the GitHub repo that contained it.
Yeah, pretty cool stuff.
In non technical news, one of my favorite authors, Mark Russinovich. That almost came out completely wrong.
How do you say it? Russinovich?
Yes, thank you.
There it is.
He released his new book last week, Rogue Code. So I don't know if you guys have read any of his the previous ones in his Jeff Aiken series. What was it? Trojan Horse and 0 Day, I believe, were the other two. Yeah. So.
And you turned me on to Damon.
Oh man,
by
yeah.
Daniel Suarez, and that was really good. So,
absolutely my favorite series.
Yeah, got to check out Daniel Suarez. Excellent
Which
stuff.
he had, in all fairness, he had a new book that came out a couple of months ago now. Shoot, I can't even remember the name
Did you
of
read
it,
that one?
I've honestly been bogged down with like technical books at the moment.
Yeah,
so
fair enough.
I have it. I bought it, and I had started to read it, and then I got pulled aside with other books. So
is that Influx?
Yes, it is. Thank you.
Yep.
All right. And that's kind of like the deal with that is basically like kind of a techno science fiction. When I say techno, I mean like coding based. So this is like sci-fi for coders.
Well, that's why I really like these two authors is that if you have never checked them out, like both of them write things that are, their storylines have a lot of technology in them. They're very technical, but they're also very plausible technology.
Yes.
And they both kind of approach it from a different angle. Like Mark
Rasinovich.
Thank you.
There you go.
He takes the approach of things that are like maybe more current times, whereas Suarez takes the approach of things that are like they're in development stages right now, and you might not be aware that the military is already using them, but they are things that are out there, but they're not as commonplace as what he might make them out in his storylines. But still, the storylines are fantastic.
Cool. So if these are more realistic and kind of techno-based or coding-based, and does the protagonist like Google every 5 minutes?
I suppose you could.
So, yeah, I mean, if it's going to be realistic, then there's got to be at least 100 searches per day. At least.
Yeah, I'll just wait for it to happen. Well, yeah, I'm not going to ruin anything about either of the books, but
All right.
Oh.
I'm just saying, like, there's some awesomeness there. If you haven't already read, if you're not familiar with either author, then you should check them out.
And we'll have them in the show notes for you.
Yep. And speaking of awesomeness, I actually just found this today, and my feelings are a little hurt. A friend of mine, turns out, I knew he went to the PowerShell Summit recently, and it turns out that he spoke there, and there's a video of his presentation online. So without him knowing it, I am mentioning it on the show here. And the name of that talk is PowerShell Module Design Rules and When to Bend Them. So definitely check that out. We'll have that link in the show notes. And in that same vein, someone else I know recently put a package up on GitHub that actually allows you to easily integrate PowerShell tasks into MS Build. So what that lets you do is maybe you have PowerShell run like code generation or something like that. Now you can schedule that as like a real build task. So you can hit F5 or Shift F5 in Visual Studio, and it's going to run your task. Pretty cool.
Very nice.
And one thing that I'm actually been looking at using that for ColorMine is actually signing my assemblies. So you can set up signing in Visual Studio, and it'll prop it right there in the proj file. And it'll link to your key, and it'll sign whenever you build like release mode. But the problem with that...
Who needs signing?
Well, so there's an article on that, which we'll be getting to coming up next. But the deal with that is if I leave it checked into the project file, that means that if I put that code up on GitHub, I either need to have that secret key embedded in my source code, bad idea, or I need to not have that stuff in my proj file. So what I do there is basically just run a little PowerShell task, and I can check that in, and I can have the PowerShell basically if that thing out there. So if the key's not there, then don't even try to sign it. And the reason that signing is important is actually detailed in a blog post by yours truly on the website. We'll have a link to that. I've basically been looking at strongly naming assemblies in NuGet and the problems that you run into mainly around key storage and open source projects. So it's kind of a unique problem to open source projects in NuGet that are strongly signed, and you should be strongly signing, so check that out. And finally, I wanted to mention a new video game that came out recently called Watchdogs. And you've probably seen a lot of press around this, and it's kind of firmly rooted in like kind of InfoSec, post-Prism world, hacking.
It's an iOS game? New iOS game?
It's not an iOS
so
game.
much.
Wait,
I'm
what?
sure there's a companion app with it. But no, nothing like that. But it's kind of had some mixed reviews.
Yeah, it's a little disappointing. I mean, I was looking forward to this one, and all the reviews I've seen have basically just slammed the storyline. So, which
is unfortunate because the advertisements really made it look like it was kind of going to tackle this kind of gray area. What's ethical, what's not. There's a lot of issues. This is a hot topic right now, but it seems like the actual game itself just kind of glossed over it.
And isn't this game way late? Because they were trying to polish it up and make sure it was going to be like the best game ever.
Yeah. Isn't that the story behind every game, though?
That's true.
Not the Call of Duties. Those things come out every November.
Right on schedule.
That's right. Now, granted, they're using the same game with a few new maps, but whatever. So
it's worth it.
Yeah, so I don't know. I might pick up this game anyways. There's not much out on the next-gen systems right now.
Yeah, when that Steam holiday sale comes around, I can get it for $9, and I'll add it to my collection of games I've never even bothered to install.
Awesome.
All right, so that's enough news. So today we're going to be talking about design patterns, specifically the creational design patterns. So there is this kind of famous book. You'll see it referred to around the internet as the Gang of Four book or the GOF book, which is really unfortunate because you can't search for that in Amazon. The name of the book is actually called Design Patterns. It just happens to be written by 4 people. And the book, I thought this was really interesting. The book was published in 1994, right? And it is still in its first edition. It's never been updated. Standalone, 1994.
Surely they must have made a typo in there somewhere.
No,
maybe
man,
a
this is
misplaced
perfect.
comma. Come on.
No, man,
Every one of them had perfect grammatical syntax. Like nothing was wrong.
No, man, this book
That's
is perfection.
crazy.
It's done.
And on Amazon, this particular book has 353 reviews and 4.5 stars.
That's impressive. And what's weird is, like, there have been talks of new patterns, and I've been surprised that they haven't added any patterns either.
Yeah, I mean, they pretty much nailed it all back when they wrote this thing.
It almost feels like they were way ahead of their time when they wrote it. And it's just taken us the last 20 years to catch up to be like, what were they talking about? Oh, that's what they meant.
Right.
So we are bringing you fresh information on this podcast on some 20-year-old information.
Right. Well, what's kind of funny about this
Hey,
is,
but
like,
we're doing it in a new way because it's podcasting, right?
That's right.
all right.
Oh, wait, podcasting isn't really that easy.
Yeah, I think there's probably been a few other podcasts on design patterns. But what I think is kind of funny about design patterns is, like, it's kind of a certain milestone or stepping stone on a developer's path. Like, there's a certain point of maturity where you kind of find out about design patterns. You go out and you learn, you read the Wikipedia article, and next thing you know, these factories start showing up in your code. And it's kind of like almost like a sign of like a junior program when you see something and you're like, oh, I see you've got 20 new factories checked in there in your latest pull request. Did somebody just get the Gang of 4 book? And so these creational patterns in particular, they're the first part of the book. So they're the kind of the classes that get joked around the most, because those are the kind of things that when people first start getting into design patterns, they start putting in all the code and then they end up kind of rebelling against it a little bit. But it's kind of funny.
Which is what we're going to focus on tonight with creational patterns.
Right. So why should you even bother studying design patterns?
Because you're in school and you had to do it. You wanted to make a good grade.
They taught you that in school?
Hold on a second. None of us learned a design pattern in school. There's no way.
Yeah, man, this book was in 94. My education consisted of nothing before 1970.
Really?
Well, interesting.
No, man, let me tell you, I can tell you the big O notation for every single sorting method. But
Okay.
not a single design pattern.
No, but I mean, this seriously, like, when we talk about schooling.
You'll have to forgive Alan. He's going through puberty.
Yeah, puberty's catching back up. I've kind of started losing my voice. So,
Actually, we should have mentioned that, though. Like, he did do a presentation, which is why he's...
yeah, I did a presentation last night. Apparently, my voice was not made for speaking that long.
Which is great that you're host of a show.
Yeah, I'm a host of a show. Apparently,
Get used to it.
I
right?
can't take much of this, so that's why I have co-hosts. So, no, I mean, but that's one of the great things about what we're going to talk about today is these are things that most people don't find out about until they get into the real world of programming, right? I mean, you don't learn about this stuff in school, and generally, you don't even understand the concepts at that point anyway. So, I think these are the steps to becoming a better programmer. So...
No doubt. And so, we kind of joke around a little bit, but there are a few reasons for studying design patterns. And I think that the main reason for me is when I see the word factory in a code base, after kind of, snickering to myself a little bit, I know exactly what that class does or what it means. It's got this kind of context behind it that I'm familiar with. So I know what to expect when I open that file. Same thing if I see a builder or, a visitor or an adapter or something like that. These things have meaning. So it allows me to kind of shortcut reading those files and understanding what's going on at a higher level.
Yeah, I'm going to stick with you wanting to make a good grade.
Yeah. All right. And just also wanted to mention there's we kind of hinted at a little bit of controversy as of late around design patterns. And that's kind of like it's almost like a little bit of a rebellion towards static languages. And so you'll see people kind of mentioning design patterns in kind of a derogatory way, and you can kind of research that on your own. But a lot of times the arguments kind of focus around these design patterns focusing on deficiencies in static languages, basically not being flexible enough and not having the kind of like language and runtime support that you would have in something like Ruby or JavaScript.
Which I won't get you guys started on JavaScript.
No, go for it.
Only because I can't fight with you about it right now.
No, this would be awesome. Let's do it. Let's hash this out right now.
But so the design patterns themselves are kind of divided into three parts. You have your creational patterns, which are your factories, builders, prototypes, and singletons. You have your structural patterns, which are your adapter, bridge, flyweight, facade, proxy, and there are several others. And then there's the behavioral patterns, observer strategy, chain of responsibility, and many others. And in future episodes, we'll be talking about a lot of these. But today, we are talking about the creational patterns.
There was a quote from the Gang of Four book here that they help make a system independent of how its objects are created, composed, and represented.
So, English, par favor.
That's fantastic Spanish there.
Yeah.
Par favor.
No, my dad was a French teacher, but I did not inherit the language gene.
You certainly did not.
No, you did.
So, so in English, they help make a. No, I won't read it again. It's just another way of trying to break. How to say this? Why'd you have to ask me in English?
All right. So, why should I care about creational patterns? Like, what does it get me?
Okay, so how about it'll promote composition over inheritance?
Wow, why do I care about that?
Because it's smaller, more focused classes.
Hey, that's starting to sound a little bit solid there.
Oh, God.
Yes.
That again.
No, because then if we did that, we're going to end up with classes that do nothing again.
Oh.
Well, that's what it's all
Smack
about.
dizzle. All right, so the idea with creational patterns is that they help encapsulate away the logic of creating classes away into separate classes, so that your classes can be created, composed, and represented outside of the logic that's actually using these things. And that to me sounds a lot like the D in solid, the dependency injection. So you're actually relying on these objects, but you don't know where they come from, whether they need certain configuration settings or whether they're talking to a database in the background or just kind of mocking it out. It doesn't really matter to the code that's using these classes because they're not newing up the objects. And there's two kind of major recurring themes in creational patterns.
But wouldn't Singleton kind of break what you just said?
That's why everyone hates them.
I set myself up. Damn it.
Boom.
All right, so I guess the main patterns we're going to be talking about today are the factory methods, factories, builders, prototypes, and singletons.
Thank you, Dr. Love.
Yes.
Yeah, one thing we should mention about these patterns, too, before we kind of dive in, is that you're already doing this stuff. It's just, even if you've never heard of the factory method, you've made a factory method before. If you've never heard of factory, you've made a factory before. These are common patterns that we run into, and the kind of the point of studying them is that you get to kind of look at the pattern separate from the business logic and kind of study that independent of any particular domain. And so it's just a good way of kind of breaking these projects up and kind of avoiding some pitfalls that you can have if you implement it in a slightly different way.
Yep. And so the first one we're going to talk about, or I'm going to attempt to talk about, are factories and factory methods. So first, let's talk about basically just a simple factory. So this is not a pattern as much as it's just a way to create objects without newing them up in your code. So when you call a particular factory, what you'll do is you may pass in a parameter. So one of the examples I found, and it might have been on Wikipedia. No, actually, this was from a Pluralsight video on factories, was you call a simple factory and you pass in the type of car you want. And in that factory, essentially all it has is a switch statement saying, hey, if you pass me in BMW, then new up an instance of a BMW car. If you passed in a Mini Cooper, then new up an instance of the Mini Cooper and return that. So in your calling code, you're not saying new BMW, new Mini. You're going to pass in, we'll say, a string potentially, and then there's going to be a switch case, a case switch statement in there that's just going to return you the type of object representing that.
But it doesn't have to be based off of input, though. It could also be
Correct.
based off of configuration values.
Config files.
Right.
For
Settings,
example.
database connection strings.
Yeah.
But usually not as much in the simple factory. That's usually more in the factory patterns themselves. And we'll get into that in just a second. So moving on to the next one is the factory method, which is This one was kind of interesting. Basically, what you have is it's the same type concept. You call a factory, but inside that factory, they are subclassing an abstract class. And when you pass in something, basically on Wikipedia, the thing that we got that was it kind of spelled it out properly is you have two game maze games is what they call. One's a maze game and one's a magic maze game. And basically what you have is you have this make room method in them. Depending on which one you when you call this factory, depending on which one you tell it you want, the method make room is going to be overridden from the subclass, and then that's what's going to return the new object. So
oh, right. I remember this conversation. Okay, so this was the one. It's kind of it's like if we were to take the template pattern, but outside of a method, and then talk about it in regards to classes.
yes,
Though, so you basically
one-off.
have the base class that has a bunch of methods that you can then choose to override
Yes.
if you want your subclass to do something different. And then when the factory method is called to, in your example, make room,
Yep.
that would be an overridden room
Correct.
or an overridden method
That returns a
that would
type
return
of
back a different
Yes.
object.
Yep. So, you could have like a magic maze, implement those methods. You could have a corn maze, implement those methods, ice maze, lava maze, whatever type of mazes. And whenever they make a room, they construct some sort of room that's applicable to their use case.
And one of the key things to note here is that I don't think we've mentioned yet is when you call one of these factories to return something, they are returning concrete type. So the magic maze, or like you said, the corn maze. But really what you're getting back is an interface. You basically have a type of the interface so that you know the methods available, but you don't actually know the type of the concrete class coming back. And that's the key. In any factory situation, you really don't want to know the exact type, typically speaking, of what's coming back, because that allows you to loosely couple your code from what you're getting back. You just know that whatever interface it implements, it has a thing called make room. And you can call this, and then it'll work. So it allows you to decouple any kind of real knowledge from what it is, as opposed to what it can just do when you call the methods.
Yeah, and just to be clear, like I was only suggesting, like it reminded me of a template pattern from a different perspective, but it's definitely not.
Yeah, I think the key there with the factory methods and how it's kind of different from a simple factory is really when you're talking about factory methods, you're pretty much always talking about more than one factory. So you've got a factory for the maze game, you've got a factory for the corny maze game, one for the ice maze. These are all separate classes that create a different flavor of maze.
Yeah, you only have one factory, but multiple classes.
Yep.
Yeah. And then you have the actual factory pattern, I believe is what this one is. It's so crazy because it's all over the board depending on where you look. But with this one, essentially what you have, this generally uses reflection quite a bit because it'll be based off either a config or something else. But your factory, you are going to instantiate a factory, a type of factory. So you're going to have an interface for factory. So let's say iAuto factory. And then you're going to have a BMW factory that extends that. You're going to have a Dodge factory that extends that. And depending on a config value or a type that you pass in, it's going to use reflection to say, okay, now I'm going to new up this type of factory. And then we know that iAuto factory has a create automobile. And then that create automobile is going to return you whatever type it is. If it happened to new up the BMW factory, then you're going to get back a BMW 335i. If it newed up the Dodge one, you're going to get back a Dodge Ram, because why would you buy anything else? So that is really
Threw me off guard there.
Does Dodge make anything else?
Viper.
Oh yeah, good point. But so that's kind of what you get there is when you get into the actual factory pattern itself, you are basically implementing an interface with multiple different types of factories, and that's how it happens. And again, it uses reflection, generally speaking, based off a config value. So like in your config, you might have BMW as the factory type that you want it to instantiate. So it's going to use reflection and say, okay, create BMW factory. Or if you have a value that you're passing at the time. But again, the whole key is you are not newing up a BMW. You're not newing up a Dodge. The factory is doing it for you, and you just know you're getting back a type of iAuto.
Yeah, and we should mention, too, that if you are confused right now, then it just means you're understanding, because this is confusing. If you try to Google this stuff, you're going to see a lot of articles that talk about the factory pattern, but give you an example of a simple factory, and you're going to see simple factories that say they're simple factories that really look more like an abstract factory. And it's just kind of confusing. But the important thing to really get out of this is that you're already probably doing stuff like this, and it's really the theory behind it, not so much the names that are important.
Yeah, generally speaking, anytime where you see that you're calling something and you're getting back an object, but you don't know what type it is, then you're probably using a factory pattern of some sort.
Yep.
And then there's the
deep end.
Yeah, the deep end here, which is abstract factory pattern. And you thought you were confused before, and I don't even know if I can explain this well with just words without having something to draw on a board.
Well, this is what we just talked about, though. Where you have the
So,
the factory, and you don't know. Okay, well, hold on. Okay, I know where you're going. Go ahead.
Yeah. So the one that I just did before was you basically have multiple factories that implement a particular factory type. When you have abstract factories, basically now what you have are factories of factories, which are even more loosely coupled, but they are all somewhat related. And so essentially you're going to have your initial factory, and instead of having just a BMW and whatever else, you might have oh god, I don't even know if I can explain this well. So you've got your BMW factory, and that might actually also have multiple factories that create cars. One's going to be a sedan, one's going to be an SUV, and one's going to be a truck, right? So you're going to have those factories of factories that way. And so if you somehow instantiate the BMW one, and then you say, all right, that's going to create an SUV, then it's going to return you back an X5. If you did it through the Dodge, you're going to get a Durango. So your top level factory then knows to instantiate the bottom level factories based off another config file or value that's passed in, and then those factories are going to return you back an iAuto of the type that you did. So again, these are all related items, but now you have factories of factories.
So
did that come across okay? I think.
Yeah, I think to really understand this, though, there's a really fun read on joelonsoftware.com. And you can search for it if you need to. We'll have a link to it in our show notes. But this will really help you to understand how factories work. And it's a forum entry by Benji Smith, and it's his general purpose tool building factory. And it'll really help explain everything you need to know about factory pattern.
Yep, and that's also including comments from its detractors. So the problem, as you might have guessed with factories, is that it is a little bit confusing to talk about. And if you're going to read about these things, then I hope you like UML, because you're going to see a lot of it.
Yeah, nobody really buys hammers anymore.
And it gets to a point where you can be so abstracted in your code that your code is just kind of like what we talked about with Solid. You're so abstracted that nothing actually does anything real anymore.
Yeah, it's a little frustrating at times, and it actually, Microsoft, if you ever look through any of their libraries of code, they use factories everywhere, right? Like almost everything they do is a factory of some sort of factory of another factory. So it's very common. So this is, if you can learn to recognize factories, you'll be a lot better off in your coding days.
Yeah, it's just a little frustrating when you come in and you're like, I just need to add an if statement, and you're wading through these factories of factories, returning factories.
So here's the interview question. When would you know that you need to use a factory?
Polymorphism. I don't know.
I was expecting you to go somewhere with
He's
that.
getting fired.
Oh.
Instead, it was just like a one-word answer.
When would you? Anytime that you know that you've already got certain types that are there, and you want to add another type, it's great for the open-close principle, right? Like you just implement another auto, right? So now Scion is a new company. You can create it, implement the same interface, and now you're pretty much ready to roll, right? Like this thing can return it back to you without having to go in and touch any of the underlying code. You're just adding additional classes, and then maybe a config.
Yeah, one real world example I like of factories in use is the if you ever used any of the AWS SDKs, then they've got this class here, the AWS client factory, that's a static class, and you say create S3 client, create Dynamo client, and it'll go and it'll read the settings out of your config file, or the ones that you've got passed in. It'll do all the stuff it needs to do to create that client for you, so you can just take that client then and do your stuff, and you don't have to worry about hooking up the values, setting your region, setting your secret ID, any of that stuff. It's all taken care of you for you by this factory.
And that's all based off your configs. So that's a perfect example of where you're not passing anything in. It just knows how to new it up pretty much. So let's talk about some of the pros of having your factory classes. First, like I said a second ago, it adheres to the open-close principle. If you ever have seen in your code anywhere, like in your main program or in a flow of something that you've got where you're doing just a ton of if-elses or a switch statement, this might, and you're newing up objects based off these if-elses, then this is probably a good place to have a factory. You can insert, and this is probably what your interview question was just a second ago.
Yeah. I was thinking along the lines of if you needed to, instantiate multiple different types, but they might all be based off of a common base class or based off of a common interface, then that's when you would want to use the factory. And then that way you have only the one place where those concrete types are being newed up rather than it being scattered throughout your code. You're using the factory to do that for you.
Right, and also if you're creating these classes in multiple spots, then you don't have to have this kind of complex logic around building these classes up and creating them. Like examples, if you're integrating like a PayPal client or something, and you want to new up that client in multiple different spots, maybe for checkouts or refunds or whatever, then you want to be able to say, just create new PayPal client, and you don't want to have to worry about digging those settings up or making sure it's configured to go to the right endpoint or any of that stuff. You want one place to take care of that. And so that might be a good example of somewhere to use like a simple factory or something where you just want to kind of create that class somewhere away from the code that's actually using it, so that the code that's using it doesn't have to worry about how to create this object.
Right, and if you wanted to take it even a step further, so instead of just getting a PayPal client, you'd say, I have multiple payment types, so then you'd have a factory of factories, right? You have a payment, and then depending on the type that's coming in, it would return you a credit card, a PayPal, or whatever.
The whole factory of factory thing is just too much, though.
Oh, it can get deep, right?
Unless you're doing some serious API level development. Like, really, when's the last time you created a factory of factories? And I think that's the point that Benji Smith was trying to get at.
But hold up, I will say this, though. A lot of being able to do that kind of thing really comes down to good design, right? So a lot of people in software don't take the time to sit down and design things up front when they're thinking about it, right? Like, this is only something that you could really do in the design phase if you really sat down.
So a greenfield application is what you're saying?
Yes, that's going to be your best bet, right? And you're actually going to have to spend some of the time in the true SDLC stuff, which a lot of people don't do, right? They just start coding and then breaking things apart. And that's why simple factories are really easy to do, because this whole thing where you see an if-else or just a ton of switches, it's easy to replace that pretty quickly. But if you didn't think ahead of time, doing this factory thing with abstract factory pattern is going to be nearly impossible.
Yeah, I mean, I'm not saying that it doesn't have its place.
Yeah.
But
you have to plan.
I'm just saying that, in the real world, I don't know that I've ever actually seen anyone do it just randomly in their code.
No, it won't be random. It'll be planned.
It'll be super planned.
Yeah. So, at any rate, that's one of the pros. Another one is it can be used with configs, as we mentioned earlier. Again, this usually relies pretty heavily on reflection.
Wait a minute. What do you mean that's a pro?
So, if you are doing testing or something like that, and you just want to be able to choose a config value, right? So,
Oh, okay. I think I see what you're saying. You're using the config as kind of like a poor man's dependency injection.
that's exactly what it is. It's how you're newing up your factories.
Sorry, I'm with you now.
So your factory might create you like a mock PayPal client or something
Correct.
like that, rather than a real one that talks to the service. Okay.
Correct. And it's basically how the factory itself is newed up, and that's going to determine the type of, again, if you put BMW in your config, it would new up a BMW auto factory that would then return you the car.
Man, if it's that easy to get one, I gotta go do that.
I know, right? The next thing is it can be used with inputs as well. So instead of having the config value, like I mentioned in the simple factory, you could just pass BMW into a factory method, and it would call create automobile and return it for you based off the text. And that's literally going to be a switch statement. So pretty easy stuff. And then the other thing that was mentioned earlier, I don't know if it was Outlaw or Joe that said it, but basically your rules for object initialization are centralized. So at this point, all your complex logic that might have been just, plopped out in the middle of one of your methods somewhere, this can now be moved to another area that's better for tidying that up, because now that logic's in one place and it's not all scattered throughout your code. So that's a huge plus, is it just makes it a little bit easier to go in and work with your code the way you need to without having to worry about all this creation business logic. And so here's some of the cons. Again, it uses reflection quite a bit. Or can use reflection quite a bit.
Yeah, I'll agree with the can part.
Yeah. I would say generally speaking, it probably does if it's anything beyond just the simple factory. If you're going past that, then it probably does. Because generally speaking, when you're doing that, because the factories are based off interfaces, you're not wanting to new that up in your code. So the whole purpose is to get away from using the new keyword, right? So in order to do that, you're going to use reflection based off either a config value or a value that was passed in through a variable. And then it's going to say, okay, what was this? Okay, it was BMW. All right, now new me up a type behind the scenes of this BMW factory.
You almost mean like inflection, not so much reflection. Like it's reacting to some sort of environment or argument.
Yes.
So not like loading up the assembly and scouring through it like system.reflection.
Yes, I agree with what you just said.
Yes.
Because when you were talking about with it being reflected, because a lot of the factory patterns I've seen, the implementation haven't been reflection based, but coincidentally, there was that article that we talked about that I published last time on the site that was reflection of control, and in it, the quote factory was using reflection to scour the type assembly,
and
as
that's what
Joe
this
put
does.
it. But I don't think that's the norm, though. Like that was just the way I implemented that particular factory, but I wouldn't say that like most factories are doing something like that.
Again, anything beyond a simple factory. A simple factory, no, because you're passing in a type and usually getting out a new object. But if you're doing the true where you have factories that are based off interfaces, then at that point it is probably using
factories that are returning an interface, you mean?
No, factories that are based off an interface. So you have auto factory, and then you have two auto factories. Okay. You have a BMW auto factory, and then you have the Dodge auto factory. Based off the value that was brought in, it's going to look through the assemblies for a Dodge auto factory and then new that up for you. That's why I say it's based off reflection. I don't know if that clarifies anything, makes it muddy or whatever. So that's one of the cons. It can be based off reflection. We'll say can.
I'll stick with the can.
All right. So, and then what was the last thing? I think that might have been it, right?
Yeah, we already mentioned Benji Smith's thing on the nobody really buys hammers anymore. This is a great read.
Oh, and then the last thing was there can be an extremely, and we talked about this, the complexity, the deep hierarchy of classes, right? Like if you do the abstract factory pattern, it can get so unwieldy that it could be really frustrating to follow that kind of stuff.
Yeah, you're creating a class to create your class, so you're definitely exploding your code a little bit.
Yeah, and it can go deep. I mean, it could be more than one or two levels, right? So
I've heard stories. All right, so that pretty much takes us through the factories and factory methods and abstract factories and yada yada. Next up is builders.
You can't yada yada over the best part.
The best part is coming up when we talk about singletons.
Oh. Okay.
Grudge match.
Oh, God. Versus.
All right, but right now we're talking about builders. And builders are different in that they're more about having your callers put together your actual object. So in the factories, factory examples we talked about, it's really the factory that knows how to put these objects together. But in the builder, it's when you don't really know what you want that object to look like. And so you need the calling code to actually put that together. And I think the best way to explain that is actually with some examples from the .NET framework. One of my favorites is the string builder. And so what you usually use string builders for is it's a convenient, great way to actually build strings in memory. And you can do stuff like loop over arrays or lists and actually append to the string builder. And when you're done kind of building this big long string, you say string builder.toString, and it generates you an object based on those kind of complex decisions that you made along the way. And maybe even a better one to mention is the actual URL builder. And that's a class where you can pass in like a domain name, and you can pass a query string. So things like that would go up in the URL arguments, request variables, get type stuff. And you can kind of compose this method by method. You say add argument, set domain. Then you say toString, and out comes your URL.
It's actually the URI builder.
Oh, look at that. I need glasses.
Yeah, so now we need a factory to create you some glasses.
I'm sure someone's made a URL builder.
So he just made himself right. See what he did there?
That's right. But what I don't know if I can explain this very well. You guys will have to help me here. But to me, the big difference between this and factories is that it's the client code that's calling the shots.
Well, I think even taking a step further, though, you're actually building it. It does exactly what it says. So you have your initial thing where you instantiate your builder class, right? Like your string builder. And then you're going to keep calling append. And so basically what it's doing is it keeps taking your inputs, and then when you're finally done, you call toString, and then it spits you out what you want at the end.
I almost fear that the string builder example might be a little too simple. I'm not saying that it's not an elegant implementation of it, but it might be a little too simple and easy to overlook the complexity of really what's happening there. But my initial takeaway from what the builder pattern does for you is use the builder pattern when you need to build complex objects. The factory pattern isn't necessarily that it's building a complex object, although it may be, but
it's hiding that complexity.
Exactly. You're not aware of any of that. Whereas with the builder pattern, you can be adding a little bit more aware of it. So in your URI example, or if you're specifying a port, or you're specifying a protocol, or you're specifying the host, like you're more aware as the caller of the parts that you're saying, like, these are the parts that I want. Now go make me a pizza. I don't care about how you had to do it. Like, I don't want to know what you had to set the oven temperature to, but I wanted some pepperoni. I want some cheese. You're going to go through the ingredient list, and then it's going to build the complex object for you.
Right, and then talking about our maze example, an example of like a maze builder here would be a class that had methods like add room, add door, add trap, something like that. And it would actually be up to the client to determine what order and how to call those arguments in order to construct its final object.
Yeah, that's actually a really good example. And then it does spit you out the thing at the end, right? Like that's the whole point, is you provide the pieces, the ingredients, as it were, and then it spits you out the final product.
Yep, so it's really the client code that's calling the shots. So that one's pretty simple.
Or by calling the shots, you mean like adding the ingredients.
Yeah, sure.
I like the idea of ingredients. The pizza thing was beautiful.
You're welcome.
Yeah. Italian outlaw.
Hey, it's a little pizza. Isn't pizza actually American, though? All right, for another show.
Yeah, I don't know.
All right, so what we got for pros then? What's some pros on the builder?
It's a great way to build a complex object. There's like I've never worked with something that had a builder suffix on it and said, "Oh man, I wish this was done some other way."
Yeah, that's a good point. It feels elegant, right? Anytime you use one.
Factory builder.
Now you're onto something.
A factory
And-
builder factory.
Hey, so seeing as how we don't have this in the tip of the week, I mean, for those who don't know what the string builder class is, shouldn't we kind of tell them why it's important?
Absolutely, you should.
Yeah, so, I mean,
Take it away, Froggy.
right, yeah. I mean, for anybody that's actually doing .NET stuff, you see a lot of times people just keep appending to a string, right? Strings are immutable. Every time you change it, it's recreating it. You're getting new space and moving it and moving it and moving it, right? With a string builder, it doesn't do that. You just keep appending to the object, correct? And then at the end of it, it creates you a string. So it's not keep moving memory locations. As far as I understand it, that's pretty much the way it works, right?
All right. All right. So, trick question then. Which one produces the faster operation? A string builder dot append, food dot append, bar dot append, and just keep on doing operations similar to that. Or concatenations with plus sign. Or string dot format and then specify all your variable pieces and then have your parameter list. Ooh. Or the last one would just be doing a bunch of string objects and then, well, I guess we already concatenated.
Yeah, that's the plus. That's the same stuff.
I know
we'll
which one
skip
I
that
like better.
The format, I think, would be faster.
All right. Format. I got format faster from Alan. Joe?
I like format better.
Okay. You like it better.
Yeah, it's more readable. You see what's going on. If it's not super long, yeah, it's just nice.
But which one do you think is faster, though? Not like better.
I like the format better.
Yeah, because if I remember right, when we go back to our boxing thing, it did not do that. It doesn't box.
So
those values.
there's actually like a lot of you can do your own Googling on this one, but there's both in the well, I'm mostly thinking of the C# world, but in other languages too, maybe, and in Java, because Java has similar concepts. There's a lot of discussion about they each have their similar versions of doing these same things, like the string.formats, for example, or the concatenations, and it's the appender, the string builder, that's going to be the faster operation. If you were to scale
Time
that
them
out,
right,
and see which operation actually was faster.
Interesting.
Over and over. Even though I'm with Joe that from a readability point of view, the string.format is so much more clear to the developer coming behind you. But depending on the language that you're working in, it might not be as good a performer.
I got a question for you here. So have you ever seen a string builder that wasn't named builder or SB?
Yeah, they're always SB.
Yeah, SB is it.
Yeah.
Or the same with URI builder.
Yeah.
It's always builder.
Is that a
URI
builder thing?
builder. I don't know.
I guess it's kind of an abstract concept.
Well, same with the factories, though, right? It's always factory.
Something factory.
Factory dot create stuff.
Yeah, all right.
Yeah,
true.
So
Maybe that's what the Gang of Four was really trying to get at. Is they just wanted us to all use common variable names.
right. Yeah.
Yeah. And it's nice that someone can see builder and know exactly what that means, but the downside is it's definitely an abstraction from your domain. So
And we got any cons then? What do we not like about the builder pattern?
Absolutely nothing.
Nothing you don't like about it.
I love that pattern.
Love it. It's your friend.
It's a little bit more verbose, but I mean, it kind of has to be, right, for what you're trying to do. So,
yeah.
I mean, it goes back to the whole thing. You're adding your ingredients one piece at a time. So, it kind of. I don't think there's any way around that.
I got a question for you. A nice theory question. Is it still a builder if it takes away? Like if I had a Starbucks class or a coffee class, and you could say stuff like add parentheses soy, add parentheses vanilla syrup. What if I have a method like remove whip or no whip?
Yeah, it's still a builder.
Yeah, same thing. It's just taking away.
You're whittling away. You're basically forming what you want this object to look like when it comes back to.
Well, I can actually back that up with a real world example. Since we were talking about the URI builder, if you were to specify the port as -1, then it won't include the port when it does the toString on it.
Ah, nice, perfect.
But if you had a port otherwise specified, or if you didn't specify -1, then it would include either the port you specified or a default.
So then I could create a class, call it a builder, and only ever have it take things away.
Potentially.
I guess
If I really wanted to annoy you.
And you're going to call it black hole, right? Black hole builder.
or
Yeah.
Destructor.
I'm going to make a little note and see if I can do something useful with this. Just to annoy everyone.
To make a Destructor.
And here we thought we were going.
I think this is how how Megatron got started.
Evil.
So I think we thought we were going to blow through builders, but it's actually kind of a fun one to talk about. So.
Well, because it's one that like you don't really think about that much, but it's out there in the wild, and you are already using it,
And it's highly useful.
But yeah, so we'll move on. So we did get some in other news. We did get some new reviews in lately, and we wanted to say that we really appreciate that. That really does help others to find us as well. So we want to give thanks back to that, and ask that if you can, give us a review, give us a rating. We really appreciate that. Like I said, it goes a long way to helping us out and helping others to find us.
Yeah, and if you don't want to type one, just go click the 5 stars. I know that's what you want to do.
Or copy someone else's and make sure it's a good one though.
Yeah, agreed. But no, seriously, the reviews are greatly appreciated. So please, if you happen to remember this after your drive listening to this, go into iTunes or Stitcher or wherever and drop us a little note.
Yeah, drop us a 5-star review and then write us and let you know what you really think.
Yeah, we're good with that.
All right, so that was our mid-episode call to action. And we've still got a few more patterns to follow up with here. So
Those
next,
crazy creational patterns.
That's right. Back to those creational patterns. And the next one I want to talk about is not really something you talk about that much, at least in C#, and that is the prototype pattern. And that's a pattern where you create new objects by cloning existing objects at runtime. And the two keywords there are cloning and runtime. And I looked for some examples in the .NET framework, and I couldn't really find any good ones. There's a clone method on system.encoding. There's one on solid color brush.clone. But I had a really hard time kind of justifying what those did. I'm sure it's really useful. I just don't know. An example you're probably more familiar with is actually JavaScript. So its whole inheritance model is built off of prototyping. And so you basically clone objects, add to them, take away, and clone. And as I mentioned, the important parts here are clone and runtime. So an example that I actually just coded up here and we'll have a link to in the show notes is like a kind of a 2D shooter, something like Gradius or 1942, or if you've never played games like this, it's you control some sort of little ship. It flies around the screen and shoots lots and lots of aliens or bad guys. And as you kind of move around on this board, you pick up power-ups, and it changes your bullets into fire or bombs or makes them shoot faster or 2 bullets at once or whatever. And so I thought,
is this how Mario got to be big?
I don't know about that one.
No? Okay.
Now you got me thinking. But that's not how I would have done it. But so for this type of game, how I kind of thought I might do it one way would be to have my ship have like a prototypical copy of a bullet, right? And this bullet could have something like a speed property and maybe a power property that tells you how much damage it does to the bad guy. And as I navigate my ship along, I can pick up power-ups and power up my bullets. But as I power up my bullet, I don't want to actually affect any of the ones that are out there now. So if I pick up like a laser power-up and I've got a bullet that I previously fired halfway across the screen, I don't want it to change, right? So every time I shoot this bullet, I make a clone of my prototypical bullet and then make it visible and shoot it off, right? So that's kind of cool, but that's not the real power, right? The real power here is that it's at runtime. So when I'm cloning these objects, I don't actually know what I'm cloning. As long as they can clone themselves, that's all I really care about. So these can be bullets that I don't even know about at compile time. So I could load like a third-party DLL if I'm, like enabled, if I have a game that's enabling mods, and I can create and shoot bullets that third parties create, which is really cool. And it'll just kind of work and plug in as long as those objects know how to create themselves via a clone method.
And that was the real key to what you were talking about, the runtime. Was
right.
Being able to pull in that plugin at runtime and just clone those, which is really cool.
Yep, I can shoot anything that knows how to clone itself. And Microsoft actually, the .NET framework actually has a method built in called clone that will do just that. And you can implement the iClonable interface, create a clone method that returns an object, unfortunately, and there you go. You've created the prototype pattern. The problem, of course, with object is that you have to cast it, and you're losing that compile time type safety.
Yeah, so you're boxing everything.
Yep, I like to think maybe if Microsoft was doing that now, they would do something with generics. They could kind of enforce that, but I haven't really fully thought that all the way out, so maybe it's not a good idea.
So anybody listening to this that had no idea what he was talking about when he said 1942 or Gradius, on the iPad, you can download R-Type.
Awesome game.
And that is very similar, and you should all go pay $1 or $2 or whatever it is and play that until you just can't play anymore.
Yeah, and if you're not super old and maybe you grew up on Unreal Tournament or whatever, it's the same kind of concept. You know, these games have mods. You can run around with a certain kind of gun, pick up a different kind of gun. It doesn't modify the bullets that you have in flight, and you can also pick up guns that are made by third parties.
Yep, very cool. All right, so what are the applicable reasons for doing this?
Well, I like to think that if you don't know what you're going to be creating at runtime. So a good example here is another game, the game of Spore. I don't know if you guys have ever seen this, but it's got like this kind of creature creator where you can walk around and eat stuff that lets you evolve things like more arms or snouts or wings or whatever. And as your little creature kind of grows and procreates and creates little babies and gradually takes over the world, then you're basically cloning these things and copying all their properties over to a next generation. And what's nice about this is you didn't have a class that specifically modeled this particular creature. It was all kind of built up at runtime, possibly using a builder pattern, and then it's cloned in order to kind of move on to the next generation and modify from there. Yeah, so that about wraps it up for prototypes. Pretty cool. We'll have a link to that GitHub project.
So I guess we want to talk about singletons then.
Nobody uses them.
Oh.
I think they were deprecated.
All right, so just strictly speaking, right, from a pure dictionary kind of point of view, right, it's a single instance of a class, right? The class itself restricts the instantiation of it so that there's only one of it. Okay?
I think if you didn't like singletons so much, I wouldn't dislike them, or I wouldn't pretend to dislike them, which is actually what I'm doing here.
Well, it's not that I like them so much. It's just that what bothers me, though, is that when people get into their little, anti-pattern crap, that I'm like, whatever. So, all right. So what does the singleton structure normally look like, right? So one of the usual suspects in your singleton class is that the constructor will be private and it'll be parameterless, right? That's the bare bones minimum normal part that you'll see to it. There's several different ways within C# and Java that you can create a singleton. I'm not necessarily going to go over all of them, but there's just briefly there's versions that you can do that where you need to worry about thread safety, some that you don't need to worry about thread safety. There's static constructor singletons. There's double check locking singletons. So there's point is that even within MSDN, there's several of them. John Skeet has written up an article where he talks about I think it was like a half dozen of the different implementations for it and what he thought were the pros and cons for it. So point is there's a bunch of them, right? And there's some that everyone likes and everyone has their opinions on it, right?
But you said parameterless constructor, and if I had to kind of take a guess at why that's important, I think it's because these classes know how to create themselves, right? That's part of their draw.
Right.
Because we don't even really know who's going to cause that creation, at least in the case of statics. We don't know who the first person to call that guy is. Yeah, that's true. So with a static constructor, you're not going to take any kind of access modifiers or parameters on it, and
it's going to be called automatically to initialize the class before the first instance is created. So this is going to be through a static constructor, the way that's going to happen. And that constructor, you can't call it directly, and you have no control over when that constructor is executed at runtime. Now, I'm not so much a fan of those, just because you have no way to do anything else with it a second time if you needed to. We'll come back to that in a little bit, but it is a popular way to do. Static constructor singletons are a popular way, and it's a valid way for some of your smaller use cases. Or, well, let me rephrase that. When you have, I like to think of it as like a simple class. Like when there's not a lot of logic to it, then then it's maybe more safer to do it that way. So, if you think that there's a chance that you could have any kind of a constructor exception thrown, then static constructor is not going to be the one for you.
Right, because you get stuck in that nasty loop.
Right. It does beg the question, though, like, if when you're implementing a singleton, if you should leave it as sealed, or if you should seal it or not, right? Because you can inherit from it.
Is that true? So I know for a static class you can't, right? So I know you can't seal a static class as far as I know, because you can't inherit from it anyway. But if you had a singleton, right, and you sealed it...
Well, I mean, the point is you only want the one.
The one, yeah.
So why would you allow for inheritance?
You wanted multiple singletons of the same type.
Yeah, and so I guess that's kind of a downside to singletons, is that you're making a decision right there that there's only ever going to be one.
Right.
Well, it's not required, right, as part of the singleton implementation, but it certainly makes it more clear to everyone who's looking at your code that
there shouldn't be more than one of these.
Right.
I don't know. I mean, what if you had a singleton class that you could subclass, right? You could subclass it, and let's say that it was two different types of connections. I don't know. Would that work? If you basically you didn't make it sealed, so you could inherit from it, but then your other two classes had the constructors that would new them up, and one basically pointed to, I don't know, one directory, and another pointed to another directory.
But the point is, though, is that your base class would have all of the implementation behind the singleton.
Yeah.
So how are you going to do that, right?
Okay, here's an example. So maybe it's not so much that I want to have two singletons around, but rather I want to use mine instead of yours. So I want to extend yours, override something, and then just only use mine.
Yeah, you could do that. You could only override certain methods in it, right?
As long as they're not static.
I mean, honestly, I've never tried to inherit from, to create a subclass of another singleton, but that seems problematic.
But you could do it. I mean, that would be the reason you wouldn't seal it, right? You could do it.
Well, what if you've got, like, we'll say
convinced.
a singleton for, like, caching, right? And this caching could hold a bunch of memory, and you might want to have basically an abstract class for that contains methods like flushing or stuff that's going to be common to all the children. So the children are all singletons.
We'll come back to that. I mean, like, the idea of inheriting from it seems to be weird, but let's move on though. So, because there's a lot to get into here, right? So there's the static constructor that we talked about, and one of the downsides to it is that if there's the possibility that anything bad can happen in it, you're not going to be able to reinitialize that. Static constructors, you can't do anything about it.
That sucks.
Yeah. There's another way that John Skeet had written about, which I actually found interesting when I stumbled across this article that he had, and we'll include a link to it in the show notes. I'd actually never seen this method done before, but I thought it was an interesting one where you have an outer class, but that the world can use, but then inside of it you have an inner private class that actually represents all the Singleton construction logic, and you can have it to be lazy initialization, but yet use because it's used by an instance field, for example, but you can what am I trying to say here?
You can delegate to that inner class. So you've got a class here that's got an instance method, right? So when you call, my class dot instance, it gets you that one single instance of it. Yeah. So, okay, I see. That's kind of cool. So you've got the class there, and then you've got this instance thing, which is basically responsible for creating that class the first time if it doesn't already exist.
Yeah, it was, like I said, it was an interesting way. I hadn't used that one in my own code before, but when I saw his take on it, I thought, well, that was a pretty neat pattern with the private inner class to represent the that static constructor Singleton.
Yeah, and there's two things I really like about that, just kind of off the cuff, and one is the lazy initialization, right? Kind of like the static, so it only creates itself after and if it's called. But my favorite part there is that seems like an easy way to reset. And that's the problem that I see with static constructors. If you've got any sort of properties there and you just want to kind of reset that back to its initial state, then you have to remember to go back and reinitialize all those settings to whatever their defaults were, which usually involves some sort of, hacky reset method or something. But in this case, you can just kind of say, set my object to null. And when you ever call that instance again, if it sees that null there, you can go ahead and create it. And it's totally from scratch, whatever the initial value should be, without you having to worry about what those were.
Interesting.
Yeah. I mean, it is trying to combine the both worlds there with the lazy initialization and the static constructor. But then there's the more, let's call it the more modern way, where depending on your version of .NET, you might be able to use this, which is the lazy of T type. So you're going to be on a .NET 4 or higher, and then in this Singleton implementation, you can pass in the delegate constructor to it, and still have your static instance, right? But
based off the type.
Yeah. So it's another interesting approach on it, but I will say that, and maybe this is just from old school, kind of stuck in my ways. My more tried and true method that I'm more of a fan of is the double checked locking version of that, where in my whatever I'm going to use to represent my instance, then I will have a check to see if the instance is null, and then grab a lock on some object, and then check it again to see if the instance is still null. And then if it is still null, then I'll new up an instance of it, and then after I break out of the ifs, I'll return that instance. So I call it a tried and true method, but that really depends on your language of choice, though.
And it's self-healing too, right? Because the static example, it crashes once, it's done. But in this case, if it crashes creating the first time, the second time comes around, it's still going to see that object as null, and it's going to try again.
Well, so that's why I really like that pattern, or that version of the Singleton, is that because it does give you some control over, you're doing lazy initialization by not newing up anything at the time that the application is loaded, but you're not doing it until you actually try to call it. So you get that advantage of it, but you have the advantage and the flexibility of saying, if I want it to reinitialize itself, I can just null it out and let it do its thing, right? Provided you provide a setter.
Yeah.
Or maybe some other way of, it doesn't have to be a setter, but some other way of having it null itself out if needed, right? But I say that comes at, depending on your language, though, because it was in Java specifically, the double check locking pattern was not recommended prior to J2SE 5.0 because there was a bug in that runtime where there could be an out of order write that would allow the instance reference to be returned before the constructor was ever executed. And so, depending on how parallel your system was and how fast it was, like you'd more often than not, you would see that cause a problem where you were expecting that the instance had been created because you were using the double check locking, but because of the bug, it hadn't yet. And so then you would get back a null reference or null pointer exception. So that's it in a nutshell. Related to some of the types now, like I said, you can easily go and look and there's at minimum a half dozen different ways on how to create how to implement a singleton, right?
Yeah, we talked about double check locking. We talked about the lazy T. We talked about inner classes, static constructors, and we even talked a little bit about kind of sealing and inheritance. Well, I'm not sure if we really said what singletons or kind of what the point was.
Okay, you're right. So, because I did go over like the base definition of it though when I said it was the single instance of a class. But
yeah, but why would I want that?
Okay, so there's a couple places some examples that you might only want one instance of the object, right? So like logging is one example that might be given. So like log for net, for example, right? You just have the one logger or log reference that's handling all of that I/O, and you're just trusting it to do it for you, right?
Okay.
That could be one example.
So so to follow along with that example, I could have used a factory there and said, create me log writer. I get my log writer and write along with all the other log writers. Or I could have a singleton called log and just say log.write. And then wherever my code calls that, I don't have to worry about creating a new client. I can just kind of go for it.
But the difference there, though, is in your scenario where you were calling your factory, right? Then you could have out-of-order writes happening to your log.
Gotcha.
And since you want these to be time-based so that you can go back through and later look at that log if you needed to replay anything or understand what happened, you want to be able to look at that log in the order of events that happen. Right?
Right.
So that might be an instance where you want to make sure that there's only one thing that's writing to that.
Right. Yeah, I want a shared stream. I don't want a whole bunch of writers writing to this file.
Well,
Right.
on top of that, also with your singleton, wow.
Go ahead, Froggy.
You've only got that one instance on the heap, right? Whereas if you're doing something like the factory, anytime you instantiate that, you're creating multiple pointers to multiple spaces on the heap.
Yep.
So,
Well, that's the point.
Memory as well, right?
But also not only the memory problems, but then if you had multiple objects all trying to write to the same file, then you could get into I/O concurrency issues too.
Right.
So logging is an example that you will often see in regards to, well, why would I want a singleton?
Well, another
Right?
place is like database connections, right?
I've got some other ones, but we'll come back to that.
Yeah, it sounds like it's useful whenever you need one object to coordinate actions across a system.
So
Thank you, Wiki.
So another thing, though, at least in the C# world, when you're implementing your singletons, you will often use your volatile keyword here to indicate that a field might be modified by multiple threads that are executing at the same time. So this will give you a good opportunity to use that one if you haven't already.
Yeah, I'm gonna have to tweet Vlad and ask him about volatile again, because as soon as he explains it to me, and it's been at least twice now, it just flies right out of my head along with regular expressions.
I love regex.
So, so I've given the brief overview of the singletons here and the different versions of it.
Yeah, so there's definitely, it makes them sound, pretty rosy there, right? It sounds nice, but if you guys are near a computer right now, I've got a little ask of you. If you could just go, open up Chrome tab, whatever, go to Google and just go ahead and type Singletons R.
Oh, well,
right?
I wasn't trying to bring you into that.
Oh, I'm sorry. Did I did I do something wrong here? Because if I say Singletons R, then the first result there, slip of tongue there, is evil. Second is bad. Third is my favorite. It's pathological liars.
Okay, well, that wasn't exactly where I was thinking that you were going to go with this.
Okay.
I had something else in mind, but me versus the rest of the world.
Oh yes,
Yeah.
Specifically, again, we'll post the link in the show notes to John Skeet's article. But if you're not already familiar with him, he's a very well respected author. I like his books, but he and I do have a difference of opinion when it comes to the preferred singleton implementation, because he's a fan of the static constructor version of the implementation, whereas, like I said, I really prefer the double-checked locking version. And if you read his article, he makes a case for it, why he doesn't like the double-checked locking, and some of that was based on language portability. So depending on the version of Java that you might be using, then maybe that's not going to be usable for you. But like I said, it's I don't like the static constructor version unless that is a simple class, right? That singleton's class. If there's any chance that singleton could throw any kind of exception, then you're hosed in it. And I like the ability that I can reinitialize it if I wanted to. And I know that some will say, like, whoa, well, if there's the possibility that it could throw an exception, then you probably just need to refactor that to begin with. There's already other problems. And I'm not going to argue that point. That's a fantastic point and a valid point. I just like the flexibility of the double-checked locking.
Yeah, it's self-healing, right? It's nice.
Yeah.
But there's something about seeing that static class there, and you know exactly what that means. There could be only one. I've never actually seen a class named something singleton, unlike the other patterns we've mentioned. So it's kind of nice to have that visual indicator. That's not a strong argument for it.
Yeah, well, I mean, as far as your naming is concerned, though, it's not as nice as the naming, though, because it's still kind of hidden, though. It's like, if your eyes happen to scan over that static keyword in front of the constructor, then you might not recognize that it's a singleton at all. Whereas at least in my mechanism, where you're using an instance property, to represent your singleton, it might be a little bit more clear to you if you were to come behind me and look at the code. Right?
Yeah. If I see .instance, I know what that means. And I've never actually seen the lazy T implementation in the wild before.
Yeah, and I think that's because depending on the .NET framework that you're working with at the time, then it may not just be available to you, or and this goes back to the portability point of view, though, is that the lazy of T is definitely going to be specific to .NET and specific versions of .NET, whereas like a double check locking mechanism or a static constructor are going to be a little bit more general purpose, right?
Yep.
So then there's the anti-pattern crap.
The naysayers.
Oh, gosh.
So I'll tell you, the thing I don't like about singletons is that they're generally a facade for global variables and global methods, like we mentioned with the logging, which is okay, but I generally think of globals as ways of kind of cheating proper encapsulation.
But no, because you're not using them necessarily to, like, a global variable to share some value that you're going to use over and over. You're using them as something to do something for you, and you only want the one.
Not necessarily. It can be used exactly like you said.
But so it's always bad to do bad programming.
Right.
Okay. But where the intent of my point a moment ago, though, was that the purpose behind it isn't to, if you're using it to store a variable that some user input, and then you want to carry it throughout the rest of your application, and that's a whole other problem that you got going on there. It's generally because you only want the one of the something, But
do you always just want one of the something? Like in the log example, that's an example of a concrete class that knows how to create itself. So my calling code, it's nice that it can just kind of say log.write. But what's gross is when my unit tests start writing logs on my CI server, something like that.
Okay, so this is where some of the anti-pattern
FUD.
Yeah, well, I was trying to think of a good word for the case comes in about that crowd doesn't like the Singleton pattern because they say, well, it mandates its own creation and lifecycle and persistence, and it makes it difficult to test. How can you mock it? Things like that. But
and you're literally kind of cementing this concrete class into your calling code. I mean, the other patterns seem to get away from concrete implementations.
Right, they're not tightly coupled.
I'm not saying that it's okay. So it can be, right, but so like a static constructor singleton, right? I could definitely see a strong argument for that being difficult to test, because if you wanted to say, let's say that you're testing your singleton class, right, and it's a static constructor singleton, then sure. Now, all your test cases that reference it, there will only be the one. So if you needed to have the ability to reinitialize it, then in your test case, you can't, right? But, for example, going back to the double-checked locking mechanism that I mentioned where, it's backed by an instance field and it can self-heal, as you put it, then you could have the ability to do some sort of a reset on it, depending on, whatever method you named, inside that singleton that would set your variable behind the scenes back to null so that it would self-heal the next time you called. Then I could see where that argument is kind of lessened as far as the inability to test the singleton.
Yeah, and bad coding is still bad coding. You can mess anything up. It just I usually see singletons in places like that are kind of scary. And so if you've got a unit test that does some stuff and it modifies the state of that singleton, then you need to make sure in all of those tests that you reset that state back to where you expected to be when you run, which is already kind of a weird situation anyway. But just something to kind of watch out for. It's definitely the biggest problem I have with it is testing.
Right, and so and that's the whole the general theme around why I'm not crazy about the static constructor singletons is that you have that inability to reset them, whether it be actually in your real production code or in your use case. Regardless, either way, you're up the creek. But another great example where you may want only one, all right, and this is going back to the beginning of the show when we talked about your factory pattern, right? You might have a case where you want your factory pattern to return back a quote null version of an object, but it's not truly null keyword, but what you're wanting to get at is return back an empty version of it. So there's another pattern that's called the Null Object pattern, right, where you return back like a safe version of an object. So, for example, the Null Object pattern could be simply if your method is supposed to return back a list, but the user didn't provide you something, rather than returning back the null keyword, you would return an empty list, and that empty list represents is used for as part of the Null Object pattern, right? So going back to the factory pattern, if you needed to return back some object that represented a null version of the object or an empty version of the object, you want to make sure that there's only one version of that null object, right? So, in Alan's factory examples, he was using cars, right? So if you had a null car, right, you only want one null car, and the reason why is for equality checks later on, right? So if you had, if that null car was able to be implemented, or instantiated multiple times, and you later wanted to say like, okay, well, did the car I just got back equal the null car? Well, that wouldn't work unless it was a singleton.
Yep. But there are other ways to kind of create singletons without actually specifying it in that class. Like the example I always come back to is dependency injection. I can actually configure as a class to only live for that application, and I can even control when it gets initialized. So then that lets me handle the persistence and keep it alive and make sure there's only ever one, but I can also control the life cycle somewhere else, like in testing or in some other way. By the way, we definitely have to thank Raj So Tweet here for getting Alan out, because he is dying. We are actually watching him. He's slumping in his chair as we speak, but he didn't want to let you down, Raj.
Yeah, no, I mean, I understand your point. So, I mean, sure, there are 1,000 ways to solve the problem, right? But my only point, like when people go on with the anti-pattern case, though, is there is a place for it, right? I mean, that, it's why it became a thing, right? If there was never a place for it, and no one ever needed this pattern, then it would have never been used. Like, maybe it would have been written about and people would have just blown it off, but clearly there was a use case for it, and it's there.
Yeah, it's very practical. A lot of times the solution you see to the whole singleton anti-pattern thing is use dependency injection, and everyone writes about that on the internet, on their blogs, and on Twitter, and then they go to their day jobs and write singletons.
Right.
Yeah. So, maybe that helps, maybe it doesn't, but
yeah. So just to kind of recap that, so singletons, their big draw is that they know how to create themselves, and so what that means is you don't have to configure these guys and create them. You don't have to new them up. You don't have to have a factory. Your guys, your client, your calling code can just go ahead and just call methods on this thing, and you don't have to worry about whether it's been created, what the state is, any of that stuff. All that life cycle stuff is handled by the class itself.
That's a good summary. I'll go with that.
Cool. So we just talked about all the creational patterns. That wraps us up. So wanted to kind of go over them real quick again. So we talked about factory methods. We talked about all the different kinds of factories. We talked about builder, string builder, URL builder.
Oh, you forgot the hammer, the factory, the tool factory, builder, factory.
Yep, don't
hammer
forget that.
Factory. We don't buy hammers anymore, though.
All right, so we talked about factories. We talked about builders. We talked about prototypes with the whole kind of weird bullet thing. And then we talked about the infamous singleton pattern. And that's it for our main topic. And
so we got some resources that we'll be including in our show notes there.
Yeah. First and foremost is that Gang of Four book, which is just called Design Patterns, even though no one ever calls it that.
Well, it does have like a subtitle, right? The elements of reusable, object-oriented.
Yeah, but the main title.
It just flies right out of your head.
Jeez.
Did you hear something? It's like a frog.
I don't know what that was. That's going to haunt me. I might not be able to sleep tonight.
I don't know if the mics can pick that depth up.
Wow.
It's creepy.
That was creepy. All right, so some other links that we'll be including in there. There's on the MSDN site, there was a great article about exploring the factory design pattern. It was a really good read. As I mentioned, John Skeet's book, he has the C# in depth. It's currently on the 3rd edition. It's a Manning publication. We'll include that as well. There's just an in general article on the MSDN site that's just design patterns in the .NET framework in general. That's also another great read. We'll include that one as well. I'm afraid for this next one.
And then there's the design patterns library, and it's a ton of content up on Pluralsight. Unbelievable.
It's like 15
Who was that
hours,
guy?
right?
That's not the same guy that we were talking to earlier tonight, right?
Yeah, you know what? I didn't even mention that. I actually spoke over a lot of Alan's talking points earlier because of his voice, and so anything that I said that didn't make sense or was just plain wrong,
Fair enough.
yeah, I was really just covering for Alan. So
Oh, okay.
Yeah. So yeah, there's. I think he was right. There's like 15 hours of material on those.
Yeah, that's definitely a long one.
and it's a long list of big names too. You know, people like Donna Belcham and Glenn Block, and you know names that you've heard before. Of course, Scott Allen. So you know these are big guys. These are the smarties.
Yeah, there's over 11 authors for that one Pluralsight episode.
Yeah, that's just like that one series, right?
Yeah.
Yeah. And they keep adding to it.
Yep.
Okay, so with that, let's get into the tips of the week. Lee Inglestone wrote a blog entry on his site, manchesterdeveloper.com, and you can find him on Twitter at Lee Inglestone. And I know I've used this feature before within Visual Studio. I don't know if you guys have, but what's really nice about this feature is that if you don't necessarily want to create a breakpoint, but you want to create some kind of a bookmark to go back and find it, right? So there is a bookmark feature within Visual Studio, and you can use the little menu items up at the top or the keyboard shortcuts. So like, for example, Control plus B and then T to toggle the bookmark on and off. And then there are additional either icons or keystrokes that you can use to toggle back and forth between the different bookmarks. Or you can use there's a bookmarks window if you turn on, you go through your view options and turn on the other windows. There's a bookmark ones, and you can see all your bookmark references all at one time. But it's just a great way of giving yourself a little placeholder for a piece of code that you might want to inspect or be interested in, but you don't necessarily want to create breakpoints. And I know in the past I've definitely used breakpoints for more than their intended purpose.
Oh yeah, I do that with undo.
Yeah,
So that was real bad. But so just to make sure, these bookmarks do what I think they do, right? I bookmark like a line in a file, then I go along my merry way, and I can say, "Oh nope, go back to where I was a few minutes ago."
Right. That's absolutely right.
Yeah, you can cycle between the bookmarks.
Okay.
So think of this as just like you would in like on a Kindle book, right? Where if you wanted to scroll between them, but instead of pages, you're looking at lines of code.
Gotcha.
So it's a nice little feature in there.
Yep.
And like I said, we'll include a link to Lee's blog article as well.
All right. So my tip of the week, if I can get this out.
I don't think you can.
Yeah.
You got to bet money on it?
I'm fading. So there's debugging object initializers. Wow. So if you've ever had a problem,
This is just comical now.
if you've ever had
I
a
want to make him talk about more stuff.
I won't make it much longer. If you've ever been trying to debug properties of an object as you create it, a lot of times you'll notice as you like try to F11 into it, it'll just step over the entire object initialization, which can be insanely frustrating. There is actually an option to where you can go into the Visual Studio settings and you can turn on object initializer. Oh, yes. Thank you. If you go into debugging general, then there is a step over properties and operations and operators, I'm sorry. And if you actually click that, it doesn't make sense. But the step over properties and operators, when you click that, it actually allows you to step through it. It sounds like it would skip over it, but that's not right. Check the box, and it'll allow you to do it line by F11.
Yep, and if you head over to the show notes for this episode at
You know what, though?
www.codingblocks.net/episode 11 or /episode 10. We actually gave this one last week as well, but we've got a really
that one
nice.
sounded familiar.
Awesome.
The good news is we've got a really nice shortcut. Screenshot, and you're not going to forget this one.
Beautiful.
Well, I feel like maybe we should make him talk about something else.
Yeah, pony up, Alan.
Wow. F3. Control.
right.
There you go. Hold on a second. So there's a quick one. If you find a keyword in your file and you want to search for it, click on the keyword, hit Control F3, and instead of having to actually do Control F and then type it in the word, it will actually go find that word where it follows next on the page. So Control F3, my quick tip of the week, and I'm done.
Yep. And what's funny about this is, as much as we talk about best practices, this is clearly a copy-paste error. Busted. All right, my tip of the week was I've been reading Clean Code. Awesome book. And one of the tips I just got out of there was it actually recommended using static methods instead of constructor overloads. And so what that means is if I, say, have a color class, right, and one of the ways I can do that is new color parentheses and pass, say, hex values, right? So I can create the color red from a string. Then, okay, that's cool. That's normal. But what's even better is to have a static method on that class called, say, from hex that can take in that same string and return the same new object, but now it's much more descriptive. So rather than me having this kind of constructor that you've got to F12 to and see if it means what you think it means, now we've got a nice, named method that does, it just tells you flat out what it does. So I thought that was a cool little life hacker tip.
Oh, so in your static method, then you're saying return new color with that hex value.
Yeah, so it's basically the same thing as
Cool.
having a constructor overload, just more descriptive.
Ah, cool.
So you don't have to rely on these stupid, summary tags in your code. You can just have the method name, be the actual description of what it's doing.
Nice.
So with that, we will be putting the show notes and links, or putting the show notes in the show notes. We'll be putting the links in the show notes and things that we've talked about. And as we've asked before, please subscribe to us on iTunes and Stitcher, and be sure to give us a rating or review using your favorite podcasting app.
Yep, and subscribe to us on iTunes, Stitcher, and more using your favorite podcasting app.
Wait, did I just say that?
I think we're all getting a little tired.
So
Alan might have got us all sick. I don't know.
all right, how about I'll wrap this up. I'll say that be sure to visit us at codingblocks.net, where you can find our show notes, examples, discussion, and more.
And contact us with a question or topic. Leave your name, preferred method of shout out, whether it's your website or Twitter, whatever you want us to promote, and we'll mention you on the podcast, and especially if you give us a review. And make sure you send any sort of feedback, questions, or anything like that, rants, funny cat pictures, to comments at codingblocks.net. And make sure you follow us on Twitter at codingblocks.
Bye. Beautiful.